Drawing lines. So how do we draw lines on an image? What do we mean by drawing lines, and why do we do that? What we mean by drawing lines is essentially addition of lines on an image in order to highlight or emphasize specific areas, and these could be region of interest. These could be if we want to label some particular components in an image, or if we want to label the image data for machine learning, then we might need to draw lines or multiple set of lines or even different shapes. So this is where we need the concept of drawing lines. And why do we actually care about drawing lines? Essentially, a line is basically a set of an infinite number of points, continuously a continuous set of points essentially. So drawing a line should not be that hard, right? It should be just consisting of a simple starting line and starting point and an end point, and we make an infinite set of points connecting those lines, connecting those points. And of course, yes, that is what a line is. But the reason why we talk about drawing lines on an image is because an image is digitized. An image is not continuous, at least a digital image. So that is why we need to translate our continuous line into these digitized blocks, or essentially translate our line to specific pixels which would represent the line in the image. So this is why we need to see how OpenCV or other tools draw lines on images. So once we have an image, we define start and end points, and we use an algorithm for digitizing our lines, and that is Bressenham's algorithm. In case of OpenCV, it digitizes the line, and then we get a line on an image. So let's look at it in a bit more detail. Let's say we have this particular image, which is a simplified image consisting of some very specific, some very a discrete number of blocks or pixels in a grid. We have a starting point, we have an end point. We want to draw a line represented by y is equal to mx plus c. We draw a line connecting the start point and the end point. And then we want to digitize it. So the specific purpose of Bresenham's algorithm is to translate the points on the line to pixels. So to have that function of transformation of the lines to specific pixels that represent the line. So first, what we do is we define the slope of the line. And for this case, I've taken the slope to be 0.4. And let's draw a horizontal line, and let's increment all the x values by 1. So each pixel, so we increment x by 1 in this case. And to point it out, I want to mention that the coordinate system is such that x is equal to 0 and y is equal to 0 at the starting point, and y-axis is positive in the upward direction and x-axis is positive in the rightward direction. And this is how it looks like. So this is x positive, this is y positive, and we increment x by 1 for each of the blocks, and we want to find out what the values of y are corresponding to these x values. So when x is equal to 0, of course y is equal to 0. When x is equal to 1, what is y? So we see that the slope is 0.4 in this case, and our simple representation of this line is, since it is starting at 0, it's just y is equal to mx. There is no c here, and so the line is represented by y is equal to 0.4x. So this is how a line is represented. If you are not familiar with the with the representation of a line, or if y is equal to mx plus c doesn't sound very familiar to you, or if you're too young, or if you're still in school and you're not familiar with these concepts, maybe watch a video or two to understand this concept, and that would be enough to follow this uh, concept explanation, hopefully. So y is equal to 0.4x. This is the equation of our line. And what is the value of y for x is equal to 1? Well, it's 0.4 into 1, so y is 0.4. The value of y for x is equal to 1, for x is equal to 2, it's 0.4 into 2, so 0.8. And for x is equal to 3, it's 0.4 into 3, 1.2, and so on. So we get the values of small y or y for each of these increments in small x or x, and y can also be called as accumulated threshold, or essentially it's just a point on y. And the reason why we use this term called accumulated threshold is because of its utility in the Bresenham's algorithm. So in this particular case, we calculated the slope. We found out our line, basically the slope of our line that we want to create. Then the next step is actually to find the x and y values, which we already did. So we increment x is equal to x by 1, we increment y by the slope, and this is essentially what we did, because it's a simplistic line that we've taken. And another thing I want to just mention briefly is that the Bresenham's algorithm can consist of more number of steps, and it can have a uh, decision parameter or decision function. I think that they also define. So it has more it has more details. The Bresenham algorithms is more complicated than I show here. But for sake of simplicity, and the fact is that the purpose is to familiarize you with how OpenCV actually digitizes a line, or how OpenCV draws a line on an image. So I've only talked about the concept on a high level. You can look at the concept in more detail in some of the references that I'll show in a bit. So okay, so we got x, we got y. We are happy with the number of with the values of y that we got, and y is called accumulated threshold. Capital X and capital Y are basically the pixel values. So as I said, we want to translate the line, which is represented in small x and small y, to our digital image, which is represented in terms of capital X and capital Y, which represent the pixel location. How do we do that? Bresenham's algorithm says that if small y, or if the value of y on the line is greater than equal to zero point 0.5, then we increment the pixel in the y direction by 1. We always increment the pixel in the x direction by 1, but we only increment the pixel in y direction by 1 when the accumulated threshold, or small y, is greater than equal to zero point 0.5 or increments of zero point 0.5. So zero point 0.5 or 1.5 or 2.5. Let's look at it in on the image. So we see that the slope here is zero point 0.4. So the accumulated threshold is zero point 0.4, and this is not greater than equal to zero point 0.5, so we won't increment y. This means that we would increment x, but y would remain the same. So this would correspond to our next point that represents the line. Let's look at point 8. Point 8 is greater than equal to zero point 0.5. Let's increment y and also x. So x and y are both incremented. 1.2 is not greater than 1.5, so we won't increment it. Again, it's x is equal to x plus 1 and y is the same, and 1.6 is greater than 1.5, so we increment x and y. So as you can see, it's already starting to roughly represent our line. Of course, the number of pixels here is not enough, the resolution of this image is not enough. That's why the line is that's why you see gaps within the line, and it might not be the most ideal representation of a line. But if we increase the number of pixels, if we have a better resolution, you can imagine that how filling in these pixels can approximate a real line, right? So likewise, we go about incrementing the values of y and x, and we hope that we get a line or an approximation of a line. So this is the whole idea of Bresenham's algorithm. And this was one particular case when our slope value was zero point 0.4, that is between -1 and 1. If the slope value is greater than 1 or less than 1 minus 1, then we actually increment y by 1, and we increment x by 1 by m. I'll not go into much details on the second case. You can search what Bresenham's algorithm is from the video that I referred, and from other references that I'll point out on the slide. if you are interested in digging more into this. But for this purpose, since you would be using an OpenCV implementation of a line, the fact that you understand what a digital line looks like is sufficient. So, what are the applications of drawing lines on images? Of course, photo editing or anything where we are playing with images, labeling data for machine learning. Um, you can imagine a lot of different applications wherever we have to draw lines or write something or essentially mark something or annotate something on the image. So these are some references you can look at if you want to learn more about Bresenham's algorithm.